The lesson topic for this video is experimental probability. Now, experimental probability is calculated in mostly the same way as probability in previous lessons, but this time our probability is based on data. So it's based on data that we receive either by performing an experiment ourselves or by having data that is collected by somebody else's collection of data or experiments. So experimental probability is always the number of trials where A occurs, so the probability of A happening is the number of trials where A occurred divided by the total number of trials. So again, very similar to theoretical probability, which we've been working on, but again, it's based on the data, based on experimental information. Okay, now we are going to perform an experiment. And what we have here is a bucket of different colored cubes, and we are going to perform several trials. So I'm just going to grab one and tally what we get. So first we start off with white. We're going to tally that we got a white one. And then I tally that I got a blue one. And so on. Oh, white again, 3 white. Yellow. Blue. Let's see that one, I don't think. All right, moving on. Black. Blue. Red. Blue. White. Green. Black. Blue. Blue. Green. Blue. Yellow. Green. White. Black. And blue. All right, I have no idea how many trials I did, but that will work for now. Okay, so let's write down how many of each we got in our chart. So the number for the experiment, we got 5 white, 2 yellow, 1 red, 3 black, 8 blue, and 2 green. The total number of tallies or trials here, we can do a little adding. Let's see here, 5, 10, 21. 21. It looks like there were 21 trials performed. And so now we could answer a set of questions on experimental probability. Okay, so let's look at these questions. In this experiment, how many outcomes are in our sample space? Well, for the experiment itself, the answer is there are 21. Okay, so let's go through and write down our experimental probabilities for selecting a white, green, or blue block. All right, so first white. Well, we found out that in our trials we got 5 white cubes out of 21. So the experimental probability to get white would be 5 out of 21. Now, looking at that as a decimal can be handy, especially when comparing it to theoretical, which we'll do in a little bit, and that would be about 0.24. Okay, now we'll go ahead and do green. Green, when we were drawing the cubes out of the box, was 2 out of 21. So 2 out of 21. And 2 out of 21 is just about 0.10. All right, and then blue, there were 8 blue out of 21. And 8 blue out of 21 is about 38.38 for that one. So those are our experimental probabilities based on the trials in the experiment. Now what we're going to talk about is the theoretical probability, which we've actually already worked on in this unit. And to do so, I'm first going to give you some information about what was actually in the box before we started, because that's going to actually help us determine our probabilities. We can't say what's the probability of getting a white if we don't know how many white ones there were in the box and how many total there were. So taking a look inside the box here, we have 1, 2, 3 white, yellow, there were 2, red, there was 1, black, 1, 2, 3, 4, blue was 1, 2, 3, 4, 5, and green, there was 2. All right, and if we add those, we have 5, 10, 17. So there's 17 blocks in the box, and those were how many of each. So now we can do our theoretical probability. So in theory, how many, when we draw them, should be white in theory? Well, there were 3 white ones inside of the box out of 17. So 3 out of 17. Now this is where that decimal can be handy, because if I do 3 divided by 17, I get 0.18. So we know that this is about 0.18, or 18% likelihood. And so if you compare these, 18 and 24%, we know that our experiment wasn't exactly what the theoretical probability would be. All right, and then green was 2 out of 17. So 2 out of 17 is going to be a smaller amount, so about 0.1, or larger, excuse me, percentage, 0.12, so about 12%. And then blue, we have 5 out of 17 of the blocks. 5 of them were blue out of 17, and 5 out of 17 is 29.29, or 29%. So again, if you compare the experimental probabilities with the theoretical probabilities, you'll see that they're not typically going to be exactly the same. They're not typically going to be, again, quote unquote, correct, because it's experimental. So it's based on trials that are random, and you don't always get what, in theory, they say you should get. Okay, we'll try another example here where I already have the data for you. It says Billy rolled a die 100 times and recorded his results in the table. So the number on the die is either going to be 1, 2, 3, 4, 5, or 6, and the number of times he rolled it, he rolled 22 ones, 17 twos, 8 threes, 14 fours, 23 fives, and 16 sixes. So question A, if you roll a die 1 time, how many outcomes are in your sample space? Well, the answer there, as you probably are aware, is 6. You can get a 1, 2, 3, 4, 5, or 6. Those are the outcomes you can get. All right, so in this experiment, how many outcomes are in your sample space? You might be thinking 6 again, because there's 6 things you can get, but that's not actually the answer. The answer is how many outcomes, in other words, how many trials, all right, did Billy have? And that is 100. There were 100 different outcomes in his experiment. So be careful with that one. Okay, so complete the table with the following. Let's start with theoretical probabilities. Okay, not based on the experiment, but based on theory. So based on theory, what's the probability of rolling a 3? Now be careful with this one as well. A lot of people will say 3 out of 6 because of that 3, but it's not, because you have to think about how many 3s are on a die. Well, there's only 1 3 on a die, and there are 6 possible outcomes, which we got from right here. So one number on the die is a 3 out of 6 possible outcomes. All right, how about the probability of a number greater than 3? Now, read that carefully, greater than 3. So numbers that are greater than 3 are 4, 5, and 6. So there are 3 possible outcomes out of, again, 6, or in other words, 1/2. What's the probability of not getting a 6? Well, which numbers are not 6? Well, 1 isn't 6, 2 isn't 6, 3 isn't 6, 4 isn't 6, and 5 isn't 6. So there's 5 outcomes that are not 6 out of the 6. The odds in favor of getting a 4. How many ways can you get a 4? Well, one way. So odds in favor of a 4 is 1. And how many ways are there to get something other than 4? Well, there are 5 other things you could get. So 1 to 5. And the odds against getting a 1, well, how many ways can I get a 1? One way. Where does that go in my fraction? It goes in the denominator because it's odds against. How many ways are there to get something other than a 1? There are 5. So those are our theoretical probabilities of each of those outcomes. Now let's check our experimental probabilities. I'm going to change this to blue. You can focus on the blue as being our experimental here. All right. The probability of getting a 3 based on our experimental results. Well, Billy got 8 3s. So 8 out of 100 were 3s. What's the probability of getting a number greater than 3? Well, greater than 3, again, not 3, not 2, not 1, but these right here, there were 14, 23, and 16. So that is 53 if you add those up. So 53 times 53 trials, there was a number greater than 3 out of 100. All right, then probability of not getting a 6 based on the experimental results. That means this 22, 17, 8, 14, and 23, all of those will be added together, and that is 84. 84 out of 100 trials were not a 6. You could have also, of course, subtracted 16 from the total of 100 to get 84. All right, odds in favor of getting a 4. All right, there were 14 4s. So 14, but remember this is not out of 100 this time. This will be out of, or this will be, the denominator will be how many were not 4s. So if we take 14 away from 100 trials, we know there are 86 trials that were not a 4. So 86. 14 to 86. And the last one, odds against a 1. Again, odds against, well, there were 22 trials that were a 1, and that goes in the bottom. And then the remaining trials, which is 78, that were not a 1, goes on the top. Okay, for time's sake, you can try D and E if you'd like, but I'm going to go on to one more thing on the next screen.